Hi guys, Mr. Mustafa here. In this video we're going to learn about higher order differentiation. If you have not watched the previous 9 videos on differentiation rules, make sure to check for link in the description box just below this video. So let us get straight into higher order differentiation and see what the setup is like. So when we say y is equal to f prime x, it means the first derivative. And what does the zeroth derivative represent? So basically the zeroth derivative basically just represent y is equal to f of x, or we can write it as, for higher order derivative we usually use this, so the zeroth derivative at x, right? So it basically means is this equal to f of x. Now when we say y prime, we're kind of finding f prime x, y double prime, f double prime x, y triple prime. Now it kind of gets like messy to keep on putting y fourth prime, so we represent it in curly brackets, f 3x, so to represent triple prime. So if we carry on, the nth derivative x is basically equal to f, represented either like this or like this. Let's take an example. Example number 1. Find the nth derivative. In other words, you need to find a pattern. Find the nth derivative of y is equal to e to the power mx. So let's see what's the rule. So solution, what we can say is we can start off with y is equal to e to the power mx, the zeroth derivative. Then the first derivative is e to the power mx times m. Second derivative is e to the power mx times derivative of the top. Again, it's going to be m squared. The third derivative is e to the power mx times m cubed. And then we can find the pattern, general pattern. So the nth derivative is equal to e to the power mx times m to the power n. So in other words, if we want to find the 100th derivative of e to the power mx, your answer will be y is equal to e to the power mx, the 100th derivative, be e to the power mx times m to the power 100. That should be a solution. Looking at the second example, if we start off with the function y is equal to cos x, right? We're going to try and find the general formula for this. So we're going to say y prime is equal to negative sine x. Differentiate negative sine x, double prime is equal to negative cos x. Differentiate negative cos x, we get triple prime, which is equal to sine x, and the derivative of sine x, which is the fourth derivative, is now equal to cos x. So this here looks like, now if I find the derivative of cos x, you're going to get negative sine, then negative cos, then sine, then back to cos x. So this here looks like is going in multiples of 4s, right? So this is going in multiples of 4s. So example, if I want to find, can't really find the nth derivative because it's going to be like quite, so if we want to find the, say, the 27th derivative, then the 27th derivative, you need to say 27 divided by 4, and you're kind of getting the remainder. So you're going to say 27 divided by 4, you're going to get a remainder 3, 6 remainder 3, so you're looking at the third derivative, which is just sine x. That's what your answer will be. If we want to find the 24th derivative, or the, yeah, say like the 24th derivative, 24, you can say 24 divided by 4 is just 6, remainder 0, so we're just looking at 0th derivative, just cos x, right? Then I'm sure we can find the nth derivative formula. You can write it as a split function. Yeah, should be able to write it as a split function in 4 parts. So it is cos x if n it is cos x if n over 4, if n over 4 gives me a remainder of 0, should be, I think it should be the modulus function, n mod 4 is equal to 0. Yes, modulus, in other words, I'm taking n, dividing it by 4, I'm getting a remainder of 0. Yes, if n mod 4 equals 0, then is equal to negative sine x if n mod 4 is equal to 1, and if it's equal to negative cos x if n mod 4 is equal to, if n mod 4 is equal to 2, and sine x if n mod 4 is equal to 3. Yep, I think that should be the solution. That's your nth derivative at x. Let's take one more example, number 3. What if I take y is equal to a power function like x to the power n? Should we take x to the power n? Yeah, x to the power n, a polynomial function. How about a x to the power n, like the power rule, right? Power rule form. What if I would try to find the nth derivative here? Let's see what we get. So if I find y prime, I'm getting a n. Okay, let's take out this value of a because it's just a constant, not gonna affect anything. So let's say n x to the power n minus 1. That's the first derivative. Second derivative is n into n minus 1 to x to the power n minus 2. Third derivative, n minus 1, n minus 2, x to the power n minus 3, and so on. I think we got the pattern here. So the nth derivative at x, so what we have is n minus 1, n minus 2, and a whole lot of this. What's happening here? We're just stopping just before 3. We're stopping at 2. So we kind of need to stop at 3, 2. So what we're going to have here now, if we're going to put an n there, n minus n will just be x to the power 0. N minus n will just be, yeah, so if when you're finding the second derivative, it is n minus 2. So it should be x to the power n minus n, which is just 0 there. Look for the pattern here. That's 3, That's the second derivative, and there's a minus 2 there. First derivative, there's a minus 1. So the nth derivative will be we will have a minus n, but we're stopping with the number just before n, which is n minus 1. So if you're going to say n minus 1, you're just going to have 3, 2, 1, which is correct. And this part over here is defined as n factorial. Right. So for an example, if I want to find the fourth derivative of x to the power of 4, y is equal to x to the power of 4, find y4. So if I want to find y4, therefore my answer will just be y is equal to 4 factorial. The fourth derivative will just be 4 factorial, which is 24. 4 times 3 times 2 times 1. Yes. Now if I have to do it in step by step, I'm going to say y prime is 4 x cubed, y double prime is 4 times 3 x squared, y triple prime is 432 x, and then y fourth prime, the y fourth prime will be 4321. 4321 x to the power 0. So basically 4 factorial, which is 6, 4 times 3 is 12, times 2, which is 24. Yeah, and that is correct solution. I hope you understand, guys, and if you don't understand this power rule and trigonometric differentiation or any other rules, make sure to watch these videos in detail, right, where I've explained the power rule, the chain rule, product rule, quotient rule, implicit differentiation, exponential rule, logarithmic differentiation, inverse trig, and higher order differentiation. So I usually start off with the general rule and I do some examples so you can catch on quickly. I hope you understood all these 10 types of differentiation, guys. If you have any questions or suggestions, make sure to comment on these video series, and if you have any inquiries, please visit my homepage and send me an email. I will be more than happy to assist you. I hope you understand, guys. Thank you. Don't forget to like this video, subscribe to my YouTube channel, and share it with your friends.